Hello students, welcome to the interesting chemistry where you will find a feeling of classroom teaching. So if you want to enjoy classroom teaching from the study room, so please watch my video of interesting chemistry. Today I am going to discuss with you the position of hydrogen in periodic table. This question has been asked so many times in your examination. So please understand how will you justify the position of hydrogen in the periodic table. As you know, the basis of the periodic table or the classification of elements is only electronic configuration. The electronic configuration tells us the position of a particular element in the periodic table. So first you should know the electronic configuration of a particular element which you are going to justify in the periodic, the position of that element in the periodic table. So today the electronic configuration of hydrogen is 1s1. With this electronic configuration, hydrogen is placed in the first A according to the Mendeleev periodic table, or in the first group in the long periodic table or the modern periodic table. Because in the first law, all the element, these are the lithium, sodium and potassium, rubidium, cesium. So hydrogen is placed with the alkali metals. Why? Because the electronic configuration of all alkali metals resembles to the hydrogen, or the electronic configuration of all alkali metals resemble to the hydrogen, that is S1, S1 and so on. So it is placed with the alkali metal in the first A or the first group. You can tell it. Again, when you go through the second point, when you go through the all alkali metals form one positive cation. So as the Li positive and Na positive, in the same manner hydrogen is also forms H positive. So this is the similarity between the alkali metals and the hydrogen. This third one, compounds. You will see here, this is as the oxides of the hydrogen and alkali metals are similar, H2O, Li2O, Na2O. These are the oxides. Then again the halides, HX and NX. So there is some similarity, no doubt. The properties of these compounds may be different, but in the formula, in the molecular formula, the compounds are similar with hydrogen, HX and NaX, Ca, Li2O. These are the similar compounds. In this way, you can justify the position of hydrogen with alkali metals. But if you on the contrary, hydrogen is a gas. Hydrogen is a gas. It forms a diatomic molecule. So it is not a proper classification. How can you justify that hydrogen is similar to the lithium, sodium, potassium? It's a gas and forms the diatomic molecule, whereas lithium, these alkali metals don't form any type of the diatomic molecule. So it is a dissimilarity in the properties of the hydrogen and other alkali metals. So now we are going to the second, with the seventh A group. So hydrogen also may be placed in the seventh A group according to the Mendeleev periodic table, or in the 17th group of the modern or the long periodic table. So how will you justify? Again I told you, you have to write, you have to see the electronic configuration. The electronic configuration of hydrogen is 1s1, whereas the halogen atoms, these are the halogen elements, the fluorine, the electron is 2p5 and here the p5. So these halogen elements are placed in the 7th group or the 17th group because their last entering electron acquires its place in the p5. So these elements are of the p types elements, but here hydrogen, this hydrogen acquires the s1. So how can you justify that the electronic configuration of hydrogen and fluorine are similar? On which point of view can do? So you have to tell the second point that hydrogen after acquiring one electron forms H ion, that is the configuration of H ion is 1s2. Now here are two electrons, so the configuration of H ion is 1s2. That is very similar to the helium 2He2 1s2. So hydrogen after acquiring the one electron forms H ion, H negative. The electronic configuration of H negative is equal to the nearest inert gas, that is helium 1s2. In the same manner, fluorine, the electronic configuration of fluorine is 2,5. After acquiring one electron F negative, the electronic configuration will be 2A, 2p6, F negative. It is just similar to the nearest electronic configuration of the inert gas, that is neon 10 2A. This is 2A. So in this way, chlorine 2,6, and after adding one electron, the electronic configuration acquires the equal to the argon 288. So here you can say this hydrogen as well as fluorine, these halogen elements, after acquiring the one electron, after adding one electron, they acquires the electronic configuration of nearest inert gas. In this way, hydrogen may be placed in the 7th group or the 17th group in this way. From the point of electronic configuration, the ion, now the summary, as hydrogen forms H negative, all the halogen elements form X negative, Cl negative, F negative, and so on. In this way, you can place. So again, this hydrogen is a diatomic molecule. Chlorine H2, all the halogen elements are diatomic, form diatomic S2. So this is the state of the fluorine. Chlorine is gaseous. Hydrogen, the physical state of hydrogen is gas. So it may be placed with the halogen atoms, with the halogen elements in the 7th group or the 17th group. So these are the two, I have discussed the two positions of hydrogen, but we see these here, the alkali metals forms the ionic compounds, and this also the halogen atoms also form the ionic compounds. But the nature of hydrogen is covalent. Mostly the compounds of hydrogen you will find in the form of a covalent compounds. So then, how can you justify that the hydrogen may be placed in the 7th A group or the 1st A group? now come to so find the similarity between the fourth group and the 14th group of the long periodic table. Carbon it is 2, 4 and it is hydrogen. I have written this electronic configuration according to the cell, according to principal quantum number. In the first cell, hydrogen has only one electron, and in the carbon, in the last in the valence cell, there are 4 electrons. They are just half, because the total capacity of the second cell is 8, and here the electrons are 4. So the carbon has only 4, just half of the total capacity of the electrons, 4. So here in this way the high capacity of the first cell is 2, and the hydrogen has only 1 electron. It is also the half number of electrons of the total capacity of the particular cell. So it can also be formed. It can also, the hydrogen also can be positioned with the 4th group and the 14th group. So the carbon forms the covalent compounds and hydrogen forms the covalent compounds. So it can be positioned with the 4th A or the 14th group of the long periodic table. In this way, hydrogen can be written and can be positioned in the first A, 7th A and the 4th A. So it is very difficult to justify the position of hydrogen in which group we can if we write here, somebody will say it can be written here. So if both are agree, then this 4th A, this one component will say that hydrogen can be written in the 4th group. So hydrogen is written on the top of the periodic table as it is. It is the position. It can be, you can this hydrogen relate to this, you can relate this hydrogen to this, and you can relate to the hydrogen this. These are the 3 positions which can be you can discuss to when you want to discuss the position of hydrogen. So that's all for today. I have given you very good content about the discuss the position of hydrogen. So please watch this period from the beginning to the end, and share to your other friends and share to your friends so that they can find the benefit of this video. So this video is very useful for you, and watch and share it. So that's all for today. Thank you very much.